I'm going to go over the review sheet. I told the kids this past week, hopefully they still remember that if they finish their whole review sheet and get everything correct, they'll get an extra 10% on their math test grade. So basically, if they're not sure how to do one of these problems, they can watch this video. They can ask you for help. The start of next week, before the test, they could ask me for help or a classmate for help. So they have plenty of options to make sure they get all these answers correct. And again, they can go from a B to an A on the test or a C to a B on a test just by doing this whole review sheet, make sure everything is correct. I'm going to go over at least one problem from every section to give them the idea of how to do the rest of the problems. And if they can't remember how to do the rest of the problems, then they can get help from you, me, a classmate, or this video again. So, I will do the first problem, which is 8/12. So it's a free answer as long as you're watching this video on 8/12. So I'm supposed to reduce or simplify each fraction. Try to get as simple as possible. Reduce means you want to make that an equal fraction but with smaller numbers. So I'm going to write 8/12 on my paper. To reduce or simplify a fraction, I have to divide the numerator and denominator by the same exact number. So I know that 4 goes into 8 and 12. So if I took 8 divided by 4 and 12 divided by 4, I would get 2/3. Those are both equivalent, and they are also, this is a simplified version. And just a quick glimpse for one time, I showed some kids a different way to do it. 8/12. I could think about what times what gives me 8. So an answer would be like 4 times 2 gives me 8. Now if I can use 4 or 2 for this 12, like 2 times what gives me 12, or 4 times what gives me 12. Well, I know 4 times 3 gives me 12. I can cross out the similar factor, and what's left over is my equivalent fraction, 2/3. I've taught both those ways of how to find an equivalent fraction that's simplified in my classroom. One more way I've taught, if you have a multiplication chart at home, or just go online, you can find one. If I look at the columns, go straight down, these are columns, straight down. If I can find a column where I see an 8 and a 12, I can find an equivalent fraction. Like there's an 8, there's a 12. So if I just go over to find the other factor, I would have 4, 6. So 4, 6 is equivalent to 8/12. A bigger one, though, if I went to these 4s, I see there's an 8 there and a 12 there. So if I just go all the way over, 8 goes to 2, 12 goes to 3, 2/3 is a better one. So there are 3 different ways I've taught different kids on how to find equivalent fractions. Depending on your child, they could do any one of those ways for that first set of problems, those ones. Next one is turn each mixed number into an improper fraction. I'll do 3 1/3 on my paper. So here is 3 1/3. Most of the kids for this one, they've already figured out that if I just do a times sign here and a plus sign here, if I do 3 times 3, which is 9, plus 1, which is 10, and then bring my same denominator down over here, I have turned this, which was a mixed number, into this, which is an improper fraction. What that looks like, just so everyone can see, there's 3 holes. I'm just try to do 3 holes kind of quickly, so I want to see everyone what we're actually doing. And I'm going to fill in all 3 of my holes, because they're holes. There's 3 holes. And here's 1/3 of another hole. So this is a mixed number, 3 holes, 1/3 of another hole. What we're trying to do is figure out how many of those third pieces do we have all together. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 of those third size pieces. The easiest trick is just do your denominator times your whole plus your numerator. So 3 times 3 is 9, plus 1 is 10. What you're doing is 3 pieces per hole times 3 holes altogether. It's 9, plus 1 more piece is 10. So that's how to do that section right there. This next one is turn an improper fraction into a mixed number. So we're going to do the opposite. I'm going to do the 8/3 one. So here is 8/3. I'll show a few different ways on how to figure this out. The way that most of the kids know is just how many 3s are in 8, and then how much is left over? Well, there are 2 3s in 8, because that gives us 6. And then 7, 8, there's 2 more pieces left over, which is my numerator. My denominator stays the same. I've also showed the kids they can do, we have 8 thirds, which means we literally have 8 thirds. There's 4, 5, 6, 7, 8. It takes 3 to make a whole. There's a hole. There's a hole. That's left over. There's 2 holes, and that's 2 left over. Some of the kids also can do this. We're doing 8 thirds, they just do 8 tallies. 2, 3, 4, 5, 6, 7, 8. And they know that takes 3 to make a hole, so there's a hole. There's a hole. I have 2 pieces left over, so that's 2 holes, and then 2 thirds left over. Another way that some of the kids have also seen it is realizing that 3 thirds makes a whole. So we count up till we get to 8 thirds. There's 6 thirds, then we do 2 more thirds that gives 8 thirds. There's 2 holes and 2 thirds. That is 1, 2, 3, 4 different ways I've shown different kids on how to do this problem. Whatever way is best for your child is fine with me, as long as they can find a way to get the answer in that section. The next section is they're going to multiply the fractions and mixed numbers. This section, probably one of the most important sections on the whole review sheet. We have these 3 that are just fractions by fractions, and then actually 4, and then these 2 that are just mixed numbers by mixed numbers. For a fraction times a fraction, you just do the numerators times the numerators, denominators times denominators. So 2 times 2 would be 4, 5 times 3 would be 5, so 4/15 would be your answer on that problem. This one, I tell the kids whenever they see like numbers they can't multiply in their heads, there's probably somewhere they can simplify. So like 14 times 9, most of the kids realize they can't do that in their head. So there's probably somewhere they can simplify. So we have 8/14 times 3/9. I'll do that one over here quickly, because majority of the kids know this process. They just sometimes don't see the simplifying in there. And I always tell them, if the numbers are big, there's probably some simplifying somewhere. So I like to tell them to rewrite this, unless they can see it by now, that there's somewhere they can simplify. Well, 8 and 14 can both be divided by 2 to make an equivalent fraction of 4/7. So I realized that, so I'm going to turn 8/14 into 4/7, because that's equivalent, same exact fraction, just, not the same fraction, it's an equivalent fraction just with smaller simplified numbers. 3/9 can both share a factor of 3, so 3 divided by 3 is 1, 9 divided by 3 is 3, so I'm going to turn that into 1/3. Now I have 4 times 1 is 4, 7 times 3 is 21, and 4/21 would be the best answer there. So they have to look for areas they can simplify. I'll do one mixed number one. I'll do this one right here. 2 2/3 times 1 3/6. 2 2/3 times 1 3/6. This is a 5-step process. First step, I have to turn each mixed number into an improper fraction. So that's this process. 3 times 2 is 6, plus 2 is 8/3. 6 times 1 is 6, plus 3 is 9/6. And multiplying. Now, I should look always for somewhere I can simplify. Well, 8 and 3, I can't do that. They don't share a factor. 9 and 6 share a factor. But if I'm smart, I can see that 8 and 6 also share a factor, and 9 and 3 share a factor. So I can do 2 of them if I go diagonal. As long as I do one numerator with one of my denominators, it's all good. So what I just rewrote this problem. I put my 8 and 9 up here, my 3 and 6 down here, and I tell the kids, you can do one numerator with any one denominator. So I'm going to do my 8 and 6, my 9 and 3. This is going to give me 4/3, because I divided them both by 2. This is going to give me 3/1, because I divided them both by 3. And now I have 12/3. I have to turn this back into a mixed number, which is that problem I showed earlier. There's 4 different ways you can do this. How many 3s are in 12? 4. If I can't remember that, I could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tallies. It takes 3 to make a whole. That means I would have 4 holes still. There's a lot of different ways I can find that answer, but 4 is that answer. All right, so that is those problems. Now, I'll go down here to this next section. And again, if I'm too fast for anyone, need more help, you can ask your parents, me, classmate, watch this video again slower, or you're more than welcome to email or text me, and I could try to work on a certain problem with you much slower if that helps out too. Now we're dividing fractions. There's one main thing. Any division problem can turn into a fraction, any division problem can turn into a multiplication problem by changing one small thing. And we made a little mnemonic device. When you're dividing a fraction and you're checking, make sure you flip the second. It's corny, I know, but we do it. When you're dividing a fraction and checking, make sure you flip the second. So the second part, there's the first part, second part. Flip the 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 second part, and flip the second part. So this one, I'll do this one. We have 2/5 divided by 2/3. So now I'm going to rewrite it, and I'm going to flip the second part. 2/5, now it's a multiplication problem, so we're flipping something, times 3/2, 3/2. So what I just did is rewrote it. This is the same. Now it's a multiplication problem, and we flipped the second part. We turned it into a reciprocal. Now we have 2 times 3 is 6, 5 times 2 is 10, and 6/10 is our answer. If your kids can see it, 3/5. We can divide those both by 2 for a simplified reduced answer. Now, that's how it's going to work for these top 3 problems, just exactly like that. These bottom 3, we have a whole number there, a whole number there, and a whole number there. I've showed the kids. I'll do only this middle one first. 1/2 divided by 8. I've showed the kids that whenever you have a whole number, you can turn it into a fraction by just literally putting a 1 underneath it. Now, that still means 8 holes. Because how many 1s are in 8? 8. So we still have 8 holes. So now we just do that, and then we do what we did before. We rewrite it as a multiplication problem. 1/2. When you're dividing a fraction and checking, make sure you flip the second. So we flip the second part. Now we have 1/16 would be the answer for that problem. 1/2 divided by 8. So we flip the second, which gave us that. So make sure you turn 6 into a fraction and flip the second part, which is 1/3. And over here, make sure you turn 3 into a fraction, and then after you turn into a fraction, then flip it. All right, those are all those. I'm going to go over all these word problems because I told the kids that they needed to make sure they tell me why I set the expression, and not just they have to explain it to me, like what's going on. And I'm going to explain it right now, so if they watch this video, they can understand it. So for the breakfast buffet, Mr. Walker cut and equally divided 12 loaves of bread over 7 platters. How many loaves of bread are placed on each platter? So we have 12 loaves of bread, and we're dividing them on 7 platters. So that means we're doing 12 divided by 7. And that's what it's going to look like, 12 divided by 7. Now, from a long time ago, I showed the kids whenever they have a division problem like this, they can turn it into a fraction very easily by just taking your first part and putting it on top, taking your second part and putting it below. You have 12/7, which can be the same as 1 5/7 by turning this improper fraction into a mixed number. So that would be the first one that they can do. The second one, Ellen has 1/3 of an hour to warm up for her gymnastics meet. She must complete each of 6 different stretches. How long in hours does she spend on each type of stretch if she spends an equal amount of time on each type of stretch without breaks? So if we think about it, she only has 1/3 of an hour to do 6 stretches. So she has to split her time up in that 1/3 of an hour between 6 things. So she's going to do 1/3 divided by 6 different stretches. So it's going to look like this. She has 1/3 of an hour to divide among 6 stretches. So again, that's what the problem will set up. Why? Because she has 1/3 of an hour to do 6 stretches. 1/3 divided by 6. What do we do before? Make sure that we turn this into a fraction, and then you'll turn a multiplication problem, and you'll flip it, and then you can find your answer for that problem. All right. Alicia and her 4 friends share 3 pizzas equally. How much of one pizza does each person get? So we have Alicia and her 4 friends. So all of that's 5 kids. Alicia plus her 4 friends gives us 5 kids. And they share 3 pizzas. So we have 3 pizzas that are being shared by 5 people. So 3 pizzas will be divided by 5 people, if that makes sense. So that means we set it up. We're going to have 3 pizzas. 3 pizzas. And we're going to divide those 3 pizzas by 5 people. So 3 divided by 5. That's why I set up that way. And a long time ago, when we have, we're dividing like this, and we can't equally divide it, our first part can be our numerator, second part can be our denominator. So that means it's going to be 3/5. So each of those 5 people will get 3/5 of a large pizza. Here's the only one I think that's really confusing, even for me. I think of this more as an addition problem, but Todd has 2 frogs. This is 1/3 number of frogs that Heather has. How many frogs does Heather have? So basically, Todd has 2 frogs. That's 1/3 the amount that Heather has. So if I did it this way, this would be 1/3 plus 1/3 plus 1/3 gives us a whole set. The whole amount. So if we did 2 and 2 for each 1/3, that means 6 would make a whole set. So Heather must have 6 frogs. Now that's how that problem, like in my brain, works mathematically. But if we're turning it into a proper equation, we're doing, it would be 2, we have 2 divided by 1/3. If we flip it to 3/1, that's going to give us 6 altogether. That's how it's set up, but I think this way makes more sense for my brain. Okay, just a couple more I'm going to do, and then we're all done. 3 more. For a snack, Miss Johnson gives her class graham crackers. She has a package of 20 graham crackers to share among 8 students. How many graham crackers should each student receive? So again, 8 students in the class, there's 20 graham crackers. Those 8 students are going to split those 20 graham crackers. So basically those 8 students are sharing those 20 graham crackers. So if we do it as a division problem, because we're sharing, we have 20 graham crackers that are being divided by 8 students. So we're going to write this, 20 graham crackers are being divided by 8 students. And that's how it's going to look. And again, and we can do this problem numerous different ways. But I showed them before that whenever you're dividing 2 whole numbers and you can't put 8 into 20 equally. You'd have a remainder. So your first part would be your numerator, 20. Your second part would be your denominator, 8ths. And that's going to give you 8 goes into 22 times. And you have 4 pieces left over, so 4 8ths left over, which basically is a half. So we could say 2 1/2. So each kid would get 2.5 graham crackers. That's how that problem would be set up, and that's how it works. All right, now we have Don has a piece of cord 40 feet long. He wants to cut the cord into pieces to tie up and support the tomato plant in his garden. How many pieces can he cut if each piece is a ½ foot long? So Don is taking 40 feet of cord and is going to divide each feet of his cord in half. So each foot is going to be cut in half. So that means he's taking 40, and out of those 40 feet, he's going to divide all those 40 feet in half. So basically, he has 40 feet of cord. If you think about it, each of those feet is going to be cut in half to 2 pieces. So he has 40, and each of those 40 is going to be cut in half. So it's kind of blurry, I'm sorry. And then if we do what we did before, we write it as a multiplication problem, 40 times 2 over 1. We turn that into a fraction 2. 40 times 2 is 80 once, which is going to do 80 of those halves. What's it going to have all together? That's why one set up that way. And this one, of the coins in Simone's collection, 5/8 are quarters. Of these quarters, 2/3 are state quarters. What fraction of Simone's quarters are state quarters? So we're literally, of these quarters, 2/3 are state quarters. So we're doing 2/3 of 5/8. 2/3 of 5/8. So if I just wrote 2/3 of 5/8, your students by now realize that of, especially with fractions, of is another word for multiplication with fractions. So we're doing 2/3 of 8, which means it's 2/3 times 8, which means that we have 10/24 of the state quarters. So 10/24 of our collection are state quarters. Or better yet, divide these both by 2, 5/12. That'd be a better fraction. 5/12 would be a better equivalent fraction. If you saw, I could have done 2 and 8. That's one numerator, one denominator. I could have simplified those into 1/4, which would give us 5/12 as well. So that's why we multiplied there, because we have 2/3 of 5/8. Whenever you have the word of as a fraction, it's multiplication. So we have 2/3 of those 5/8. I hope this helps. If it doesn't, watch the video again. Ask your parents. Parents, text or call me. Ask me for help tomorrow, not tomorrow, but Monday or Tuesday morning. Ask a classmate who does get it for help. So you get all of these correct. If you get them all correct, it's an extra 10%. All right, take care. Bye.